בבקשה מיוט. Okay, so for those of you who don't speak Hebrew, I'm going to start with a short Hebrew introduction, and then Amit will start the session in English. אז שלום לכולם, אנחנו בעוד מיטאפ, אני רואה שאנשים מצטרפים, אני מניח שיצטרפו תוך כדי, נתחיל בכל מיני הודעות וכאלה, תמיד יש פרצופים חדשים פה, אז חשוב לי שאנשים יכירו. אז ככה, אז קצת לינקים וכאלה להצטרפות, אנחנו נמצאים במיטאפ, להירשם לכל האירועים שאנחנו עושים, הכל נמצא פה, אני מתחיל לשים דברים בצ'אט, אתם יכולים לקחת את כל הלינקים משם, יש לנו קבוצה בפייסבוק, הרבה מאוד אנשים משתתפים שם בשאלות, תשובות, אנשים שמחפשים עבודה, מחפשים עובדים, מחפשים חברים, או כל דבר אחר, זה בקבוצת פייסבוק שלנו, שנמצאת עכשיו בצ'אט. ערוץ היוטיוב, לשם אנחנו מעלים את כל ההקלטות של המפגשים האלה, ועוד הרבה דברים אחרים שעשינו בעבר, יש שם כבר ארכיון די עשיר של סשנים כאלה ואחרים, אפשר לחפש שם ולמצוא הרבה דברים מעניינים, מומלץ להירשם, ואז בעצם תקבלו עדכונים כל פעם שעולה משהו חדש. יש לנו את פודקאסט, SQL Server Radio, אני ואיתן בלומין, מדברים על כל מה שקשור ל-SQL Server, מוצאים תוכנית פעם בחודש, אני שם לכם פה בצ'אט את הלינק לתוכניות בעברית, זה SQL Server Radio COIL, אותו דבר עם .com בסוף, זה תוכניות באנגלית, אנחנו עושים עברית ואנגלית, פעם בחודש, כל מה שקשור ל-SQL Server, אם זה מעניין אתכם, אתם רוצים בפורמט של פודקאסט, תוך כדי נהיגה, תוך כדי ריצה, תוך כדי שטיפת כלים, אז זה בשבילכם. משהו מאוד מומלץ, למי שלא מכיר, ערוץ הטלגרם שלנו, שנקרא המומחים של מדרה, יש שם הרבה מאוד אנשים, יותר אינסטנס, שאלות ותשובות, דיונים מקצועיים, יש לכם שאלה מקצועית כלשהי, זרקו אותה שם, סיכוי טוב שמישהו יענה לכם יחסית מהר, לא רק אנשים שלנו במדרה, גם אנשים מהקהילה, אביעד למשל שנמצא פה, תודה אביעד, מאוד מאוד פעיל שם ונותן אחלה תשובות להרבה אנשים, אז אם אתם רוצים לקבל תשובה מאביעד, אז תצטרפו ותשלחו לשם את השאלה, לא שמתי את זה, נכון? רגע, נעלם לי הצ'אט, איך זה קרה? פה, מצאתי אותו. סליחה. זה הפודקאסט, וזה המומחים של מדרה, הכל בצ'אט. ודבר אחרון, מבחינת לינקים שימושיים וכאלה, מדרה טולבוקס, ריפוזיטורי שלנו בגיטאב, שלשם אנחנו מעלים סקריפטים, פתרונות, דברים שאנחנו מפתחים, יש שם המון דברים, ואנחנו ממשיכים להוסיף לשם כל הזמן, אז גם שם תיכנסו, תחפשו, תשתמשו בדברים שיש שם, אתם מוזמנים לתרום גם, להוסיף לשם דברים, לדבר איתנו על זה, לעשות סאבסקרייב, כדי לקבל עדכונים שעולים דברים חדשים, אז זה יותר בצד הטכני, דברים שנמצאים שם. זה מבחינת לינקים. התחלתי איזושהי מסורת, כל פעם לוקח איזשהו בלוג שכתב מישהו מהקהילה שלנו, ונותן לו במה, אז איתן בלומין, זה שהזכרתי קודם מהפודקאסט, לפני יומיים נראה לי, פרסם באתר שלו בלוג על Extended Properties ב-SQL Server, מי שלא מכיר יש פיצ'ר כזה, Extended Properties, לא משתמשים בו יותר מדי, סוג של מטה דאטה כזה, נועד לתאר אובייקטים, אפשר להצמיד properties, זה key value כזה גנרי, אפשר להצמיד את זה לטבלאות, לפרוצדורות, ל-views, למה שאתם רוצים, ולתאר אותם, משתמשים בזה, אם משתמשים בזה, אז בדרך כלל זה לצורכי תיעוד, אבל יכול להיות שזה כל מיני שימושים אחרים. איתן כתב בלוג פוסט מעניין על כל מיני use cases ושימושים שהוא מצא לזה, אפשר להתווכח על זה, כן או לא, מתאים לא מתאים, אבל לפחות כדאי להכיר ולפתח קצת, לפתוח את הראש לרעיונות כאלה, אז מוזמנים להסתכל בבלוג הזה של איתן, אני שם לכם גם את זה בצ'אט, ממש עכשיו, הנה זה קורה. כרגיל, השוק היום בוער, כולם מחפשים עובדים, ויש כאלה שמחפשים עבודה, ואנחנו פה בשביל לעזור לקהילה ולעשות את המאצ'ים האלה, אז אם מישהו רוצה להציג את עצמו בתור מי שמחפש עובדים, מחפש עבודה עכשיו או אחר כך לפנות אליי באופן אישי, או בקבוצה שלנו בפייסבוק, אתם לגמרי מוזמנים, זה חלק מהמטרה של הקהילה הזאת, וכרגיל, אנחנו במדרה גם מחפשים, אז אני תמיד גם מזכיר, אנחנו מחפשים גם DBAים, גם Data Engineers, גם Data Analysts, מפתחי BI, הרבה Azure, אז מי שמכיר ויש לו ניסיון וידע באזורים האלה ורוצה להתפתח מקצועית, יש לנו הרבה מה להציע, ואם אתם מכירים מישהו אחר, שאתם חושבים שיכול לעניין אותו, אז נשמח שתשלחו אליי גם כן. אני שולח לכם פה בצ'אט לינק למשרה שלנו בלינקדאין, למי שמעוניין, תגיש מועמדות, או כמובן תפנו אליי באופן אישי, זה גם כן תמיד עובד. אירועים, זה החלק האחרון. אז היה לנו פעם שעברה, לפני שבוע, הרצאה מאוד מעניינת של ניקו נויגבאואר ממייקרוסופט על Azure SQL Managed Instance. הוא ביקש לא להקליט, אז לצערי מי שלא היה הפסיד, אין הקלטה של המפגש ההוא. האמת היא שגם אותו שלח לי את ה...
הייתה פגישה נהדרת אגב, רק לציין, היה ממש מצוין.
כן, יאיר היה שותף פעיל מאוד בפגישה הזאת, תודה יאיר. אז היה סשן של ניקו ויאיר בפעם שעברה, ויש פה את הלינק לפגישה, אם אתם רוצים לראות מה היה וכולי. האמת שאותו שלח לי את הדק שלו ואת החומרים וזה, אז אין לי שם יותר מדי מה למצוא כרגע, אני מקווה שבקרוב ישלח לי ואני אעלה את זה. זה מה שהיה פעם שעברה. מה יש לנו בקרוב? אז יש לנו בשבוע הבא, העליתי את זה היום, זה ממש טרי, ב4 לאוגוסט, חברת גודאט הולכת לדבר על מוצר BI מאוד מעניין, שהם פיתחו, שווה לשמוע, זה ב4 לאוגוסט, יש פה, סליחה, זה, אני אעלה לכם גם את הלינק של זה, לי פה מוכן, לא נורא, תמצאו אותנו במיטאפ. דאטיברס, דיברתי את הפעם שעברה, ב-13 לאוגוסט, אירוע מאוד מעניין, מהיוצרים של דאטה גרילנד בגרמניה, זה באירופה אמנם, אבל זה הכל, אתם יודעים, אונליין היום, אז גם זה יהיה אונליין, ושם הדגש יותר על אנשים שבדרך כלל לא מופיעים על במה, לתת להם הזדמנות, לתת צ'אנס, אז אנשים שאנחנו פחות מכירים, הזדמנות לשמוע על כל מיני נושאים, בעולמות של דאטה פלטפורם, מזוויות אחרות קצת, מאנשים אחרים, אז מי שרוצה מוזמן להירשם גם לזה, אני שם את זה עכשיו בצ'אט. מעולה. מה עוד יש לנו? ב-17 לאוגוסט, אותו איתן בלומין, הקרצייה הזה, כל הזמן שאני מזכיר אותו, אז הוא שותף להרבה דברים שאנחנו עושים, אז ב-17 לאוגוסט הוא הולך לדבר על איך לחסוך כסף על SQL Server Hardware. כל מיני דברים שכדאי לדעת, על ארכיטקטורה של שרתים, נומנוד, כאלה ואחרים, ואיך להשתמש בלייסנסינג בצורה נכונה, להקצות משאבים בצורה נכונה. אנחנו מתקלים אצל לקוחות בכל מיני מצבים, שלקוחות אפילו לא מודעים, שלא מנצלים את כל ה-CPU, את כל הזיכרון על המחשב, למרות שהם משלמים עליו גם על החומרה עצמה וגם על הלייסנס, אבל בגלל מגבלות של הרישיונות, הם לא מנצלים את זה בכלל. כדאי לדעת, יש כל מיני מגבלות שונות בין סטנדרט לאנטרפרייז, וכולי וכולי, ובאז'ור בכלל זה סיפור אחר. אז כדאי להכיר, זה יקרה ב-17 לאוגוסט, וזה הלינק להירשם להרצאה הזאת. מה יש לנו אחרי זה? במסגרת ההדרכות של מייקרוסופט, למייקרוסופט יש הרבה הדרכות כל הזמן, בחינם, אפשר להצטרף, צריך להירשם מראש, יש שם הרבה, תיכנסו ללינק שמופיע פה, נשים אותו גם כן עכשיו בזה, ואפשר משם להגיע לעוד הרבה מאוד, זה לינק להדרכה ספציפית הזאת, אפשר להגיע לעוד הרבה מאוד הדרכות אחרות, ההדרכה הספציפית הזאת זה לגבי סינאפס אנליטיקס, זה בעצם יומיים, כל יום משהו כמו 3 שעות אם אני לא טועה, משהו כזה, יש לכם פה את התאריכים, זה ב2 שעון ישראל, אתם נרשמים, מצטרפים להדרכות האלה, בסיום ההדרכה אתם גם מקבלים ואוצ'ר, לגשת למבחן ההסמכה של מייקרוסופט, אם אתם רוצים לעבור את ההסמכה אחר כך, אז מי שבעניין מומלץ. זה מבחינת אירועים, נכון לעכשיו, יש עוד הרבה דברים בקנה כמובן שנוסיף בקרוב. אני רוצה להזכיר, כמו תמיד, call for stickers, אנחנו מחפשים עוד ועוד אנשים מהקהילה שיבואו להרצות, לדבר על נושאים כאלה ואחרים. זה לא חייב להיות פורמט מסוים, כמו לספר על איזשהו פיצ'ר כזה, זה יכול להיות סיפור לקוח, סיפור על פרויקט מסוים שפיתחתם, דברים שעשיתם בעצמכם, מה שקשור יותר לפיתוח קריירה דווקא בתחום, זה יכול להיות הרבה מאוד דברים, כמובן שקשורים לעולמות של דאטה, שבהם אנחנו עוסקים. יש פה את הלינק, אני שם גם אותו עכשיו בצ'אט, נשמח מאוד אם עוד ועוד אנשים ישלחו לשם אבסטרקט, יציעו את עצמם, זה, אני אדבר איתכם, אני אשמח לעזור, למי שרוצה להתייעץ איתי, איזה נושאים, איך לכתוב אבסטרקט, אני אשמח לעזור גם בהקשר הזה. וזהו, והיום, עכשיו, אחרי שתחנתי לכם במוח, עמית בנסל, דאטה פלטפורם MVP, עומד בראש כמה ארגונים למעשה, יוזר גרופ ודאטה גיקס בהודו, מארגן כנס ברמה בינלאומית, שנה שעברה היה כנס מדהים, ענק, בספטמבר הולך להיות אירוע עוד פעם, המון ניסיון בידע בעולמות של SQL Server, ידבר איתנו היום על פרפורמנס טיונינג, אני יודע שזה תחום שמעניין הרבה מאוד אנשים, ולראיה גם המון אנשים נרשמו ובאו לפה עכשיו, אז עמית, it's all yours, I'm done.
All right, thank you so much, Guy, and I totally impressed with so many things that you and your community is doing around data platform.
Thank you.
And lovely, so many upcoming events and meetups, and then the way I see the sessions are being put up on YouTube for people to watch later. I mean,
Yes.
I couldn't understand what you were saying, but I followed the slides.
Okay. At least the
So
slides are in English.
yes, at least the slides are English, so I could figure out what's going on. And yes, very, very impressive. So thank you for everything that you do. And hello, everyone. Welcome and welcome to this session, 6 techniques to get SQL Server Speedometer go crazy. Thanks for this opportunity to present this session to the Israel Data Platform Community Group. Thanks to Guy and his team for selecting this session and giving me this opportunity. I will get started. And if,
Amit, would you like
of
me
course,
to monitor the chat for you, or would you like to do it yourself? If there are any questions from the audience?
yes, when I share the screen, I won't be able to see the chat
Okay.
window. So if we have 2 options, what do I mean? I'm okay with either one. I mean, based, you know, what the audience preference there is. If would they like me to answer the question the moment it is put up or after the session? Either way is fine for me.
So I'll try to interrupt you in places that I think are
Yeah.
okay.
Absolutely, absolutely works best. I
Okay.
think the audience would like if the question gets answered then and there. It becomes easy
Okay.
to follow up what comes after that.
Exactly.
So yes, and friends, English is not my first language either, so I am going to speak slow and make sure that whatever I say is understandable to you. If I'm too slow or too fast, just you know, ping me, no problems at all. So let's get started. I am going to share the content and click on Windows, and there you go. So this is how it should be shown. So if you can please confirm, can you see the management studio?
Yes.
Okay, perfect. Right, friends. So the session is 6 techniques to make SQL Server Speedometer go crazy. My name is Amit, and I have been working with SQL Server for a couple of years now. I'm on Twitter. This is the handle A_Bansal. I work for a company called SQLmaestros.com, and I think I was talking about my community work, which is associated with Data Platform Geeks, SQL Server Geeks, and Data Platform Virtual Summit. All the scripts resources are hosted on this URL. The links are there in the chat window. You may just want to kind of copy paste and save it for your reference later. You can also connect here on my newsletter. Very recently, we launched a SQL Server magazine. It's free for the community. You may want to download your copy. 3 editions are already out. After the session is over, irrespective whether you like the content or not, you can put your feedback and tag me as well with A_Bansal. I do not have any more slides. I mean, well, there was no slides. This was the first one. So no slides, no PPT. We are just going to go into the demos. So what is the content all about? So before I jump into these 6 techniques, let's talk a bit about the motivation. The motivation, the idea behind most of my sessions are that when we work on SQL Server with customers, small scale, medium, large deployments, there are a lot of learnings that we get while we work on these projects. Most of my assignments are related to performance tuning and optimization. And I can tell you, we learn a lot of stuff from books, from blog posts, by attending sessions, but what we learn while doing stuff is completely unmatched. And those are the real world learnings, practical learnings that I get. And the intention is to bring those learnings and give it to you here with those sessions. So all the learnings that I had, I tried to make academic prototypes of it, and I packaged them into demos so that you get those practical learnings. That's the motivation. So the demos here are a bit fragile. When I say fragile, I'm not trying to say that they won't work. They will hopefully work, but let's be a bit patient with the demos because performance is all about looking at some numbers and trying to stress SQL Server and compare the good versus bad, the bad versus ugly. So be patient and hopefully things will work fine. The recommendations that you're going to see here, the techniques that I talk about are not blanket recommendations. If they are blanket recommendations, I will call it out. But as you know, the safest answer in SQL Server world is it depends. So there are a lot of different what would I say, surrounding circumstances. I mean, the configurations, the scenarios, the hardware, the software, the workload, the querying pattern. A lot of other external and internal factors need to be taken care of before you decide to implement a technique or a configuration option. So what you learn from here, don't please assume that I'm just going to take it and deploy it in my SQL Server and it's going to work like a magic. Please, that will not happen. You got to evaluate a lot of different things. So with this, let's get started. I will close this one and jump over to the first one. So let me go to this folder, and when you are downloading the scripts, you will also get a folder like this, 6 techniques speedometer, and these are the 6 ones that we are going to see today. We're going to see something with Temp Db, then we are going to look at parallelism, and specifically we will look at cost threshold of parallelism. We are going to look at a server option called optimize for ad hoc workloads. Then we're going to look at a database option, a database property called forced parameterization. We will look at the 5th one is going to be on read committed snapshot as to what exactly that is and how can that be helpful. And the last one will be on data compression. These are the 6 techniques. No specific order per se, just try to see what they are and how it helps and evaluate if they're good for your environment. So let's get started with the first one, Temp Db. And this is the most easiest one, and this is like a warm up. So this is something that all of you know and easy to kind of show, easy to produce the numbers, and this will warm us up for the upcoming demos. So first, what I have done is, because this demo is running on SQL Server 2019, I have removed the additional database data files for TempDB, because you know in SQL Server 2019, during installation, you can configure SQL Server to have multiple TempDB data files. So what I've done right now, and I'm calling this out because when you're practicing these demos with the scripts, you need to know what's the purpose of each of these scripts. So first, what I do is I'm using TempDB and I'm checking, okay, how many files we have here. And ideally, if you're doing this in SQL Server 2019, you may see that there's 1 log file and 8 data files. And then we shrink them and empty them, and then we remove them. So this is something that I've already done just to save some time in the demo. And now finally, I have, for some reason, I was not able to remove 1 file. So I have 2 data files, if you see here, and 1 log file. So what is this demo about? The first technique is about adding multiple data files to your TempDB database. This is something which is, as a best practice, is very, very popular and has been called out so many times. And I am SQL Server professionals know this for many years. But surprisingly, I still come across environments every now and then where this best practice is not followed. And every time I come across an environment, it really surprises me as to why a SQL Server deployment has not followed this best practice, because this is a proven best practice. Out of the 6 techniques that I'm showing you today, if there is one technique which you can take as a blanket recommendation, probably this is the one. And I do not know, maybe a very, very rare or exceptional scenario where you would kind of decide, no, I will stick to 1 data file for TempDB. I can't think of that on top of my head, which means that if you're running on all these latest versions of SQL Server, 19, 18, 19, 17, 16, 14, 12, you should ensure that you have multiple data files. Now, the question is, for those of you who are not well versed with this concept of multiple data files, why would you do that? Why would you go and add multiple data files to TempDB? And why is SQL Server by default giving you just 1 data file if the best practice so strongly is to have multiple data files? So let's call this out first. Probably, and I don't know if Guy can correct me there, excepting SQL Server 2019, I think all the previous versions during installation, they by default add 1 data file. Only in 2019, right, during installation, you have this option of configuring multiple data files. So that's a great improvement of, when you talk about the installation and setup feature in SQL Server. So of course, there's no not to criticize Microsoft here that this thing was done much later, but anyway, now if you're installing all other versions of SQL, you do the installation and then later you reconfigure. So today this is one of those immediate checklist, as we call it, things to do immediately after deployment is to configure multiple data files, pre-size them, so on and so forth. So let's come back to the question as to why do you need? Well, the idea is to reduce Temp Db contention. Temp Db is a database where you store temporary objects. So you will create local temporary tables, global temporary tables. They all go into Temp Db. Even table variables go into Temp Db. SQL Server internally will use Temp Db for all its work files and work tables, like when you are doing expensive hash or expensive sort operations. SQL Server tends to use Temp Db to store that intermediate result sets. A lot of features inside SQL Server also use Temp Db. For example, row versioning, and which I'm going to demonstrate today. And there are a couple of other features that use Temp Db. So if you see, Temp Db is being used so heavily. What happens is in under a heavy production, when SQL Server is being bombarded with a lot of workloads and users hitting, and your application is in this business of creating a lot of temporary objects, then there is contention in Temp Db. Now, when we say contention in Temp Db, what exactly do we mean? Well, each data file in SQL Server architecture has global allocation map, shared global allocation map, and page free space page. So PFS page, as we call it. These are system pages. In short, we call them as GAM, SGAM, and PFS. And I'm sure at some point you have heard of these terms. We don't work with these system pages quite often. I mean, we don't even come across that, and we have no business to really tamper or touch or kind of work with them on daily basis. But internally, what happens? Whenever objects are created inside TempDB and whenever objects are destroyed in TempDB, SQL Server runs allocation and deallocation code in TempDB, and these allocations and deallocations code are going to touch these system pages. Now think about hundreds of users hitting your SQL Server, trying to create all sorts of temporary objects, and after the job is done, they would destroy it, which means all of them need simultaneous access to these system pages, which means contention is going to be there. Why? Because at any given point of time, only one user will have access to these system pages. Idea is very simple, because these are end of the day 8K kilobytes system page, and they are in the memory area, and they have to be protected. So they are latched to ensure that there is physical integrity of the page. So if your user, that connection, is making change to that system page, it is one at a time, which means all others are waiting to get access to that page, and that wait is what we call as latch contention. In other words, latch contention in TempDB with these pages is what we call as TempDB contention. Sometimes we also call them as buffer latches, etc. Well, these are different terminologies, but the bottom line is there is TempDB contention happening. Now, the demo here is not to show you how and when TempDB contention really happens, though I'll briefly do that, but that's the background. Of course, if there are questions, please feel free to put them in the chat window. So it was very important to quickly give you that background as to how and why that contention happens. Now you can understand. Now the point is, what is the correlation between this contention background that I talked about with the number of data files? Well, these system pages that I talked about, GAM, SGAM, they are one per data file. Ideally, they're one per data file. PFS page gets additional PFS page gets added when you cross a certain limit, but typically speaking, they're one per data file. And the idea is simple. If you have one per data file and everyone is going and hitting that data file, there is going to be contention with these pages. So you add more data files. If you add more data files, it's like a highway, right? And you know, like highway is a 8-lane highway and all the cars are coming in. But when you enter the city, it's just one road. So all highways merge into that one road, causing contention at that junction. But when you have 8 data files, you have 8 GAMs, 8 SGAMs, and let's say you have 8 PFS. I'm assuming we are adding 8 data files. So the contention gets spread out and the wait time reduces and your workload just seems to be running faster. That's the idea. immediately a question will come to your mind. Hey, Amit, you're saying 8 files. What about adding 16 files or 32 files? Well, you can add, nothing stops you from adding more data files, but then it goes, there's a bit of debate there as to how many processors do you have. Microsoft's logic and best practice says that, okay, you can add one data file per logical CPU. So if we take that theory, if we take that as an example, suppose you're running a box with 128 logical CPUs. Question is, can you add 128 Temp db data files? Theoretically speaking, yes, you can add. Technically speaking, yes, you can add. Practically speaking, yes, you can add, but I have not seen a lot of customers with like 128 data files or 256 data files. Today, you even have servers with like 512 logical CPUs, right? That would not really mean that you add 512 TempDB data files. So 8, 16, that number is very, very safe to go with. And if I say 8 and 16 is safe to go with, am I trying to say 32 and 64, that number is not safe to go with? No, I'm not saying that. You just got to test it out. If it works for you, fair enough. There are ways on how you can add those files, monitor for some time by looking at some numbers. If things go well, it's all great. But if you think the numbers are going bad beyond, in comparison to your baseline, you may want to scale back. So, that's a larger discussion, but 8 and 16 is good to go with. Now let's go back to the folder, and it's time to jump into the demo. So we have reconfigured. Now I have only 2 data files. The demo will work fine with even 2 data files. And here is the second part of the demo. So which is after reconfiguration, now I am going to check some weight stats. So if you see, there are 3 types of weight I am checking here: page latch sh, up, and ex, which stands for shared, update, and exclusive. This is, I'm checking these weight types using this dmvsys dmos weight stat, but these are not necessarily only related to TempDB, but at this point of time, I'm running the demo and I'm only going to stress TempDB, so good enough. So let's go and execute this right now, and you can see that there are some numbers out there. I've just restarted SQL Server, so of course the numbers are very low. And for the purpose of demo, let's go and clear the weight stats and reset everything back to 0. So SQL Server perf, dbcc SQL perf sysdmos weight stats clear. That is a statement that you can run to clear off the weight stats. Be careful, don't run such statements on production, because that may have adverse effect in sense someone may really want to track weight stats, and you're going to reset everything back to 0. So you're going to get some people upset about that. So there you go with all 0, and we are good to start. Now I'm going to run the workload. There is a file here called workload.sql. Let's go and see what this file does. So in this file, if you see, we are running a while loop. I'm creating a temporary table, and now you know why am I doing that? Simply because I want to create allocation inside TempDB. Then I insert some data, and then at the end of this, I drop the table. So this is just slightly engineered for the purpose of causing some activity inside TempDB. And then here is stress.cmd. This is the command file that I'm going to launch. And I am using a tool called ostress.exe, which comes from a free package tool called rmutils, which is RML utilities created by Microsoft SQL team. This is the only utility that gets installed by default in a folder called Microsoft Corporation. Everything else goes into Microsoft, but this is the only one that goes into Microsoft Corporation anyway. And we are going to create 20 users, and they're going to repeat this for 10 times. So that's like N20 and R20 parameters. So what are we going to observe? We are going to stress SQL Server with this, and with 20 users, we are not really stressing, but good enough for us to watch the numbers. So you're going to see 2 things. One is how long does it take for the workload to complete, and after it completes, we are going to go back and look at our weight stats here. This is what we are going to see. So let's get started with the first demo. So we are running this, and it's running, and let's go and look at the numbers. So you can see that as the workload runs, the numbers are counting up. I am constantly refreshing this. So look at page latch shared and update, because sh and up are the ones that are going to be affected the most with this, and there's good wait time also happening. And we're just going up and up as the number keeps counting up. So these are 20 users running in iteration of 10 each, creating and destroying objects. So I think this is done now. So let's go back and see that this operation took about 32 seconds to complete. Keep this number in mind. So let's close this 32 seconds and let's record this as well. So I'm going to copy this with headers and let's take one of my favorite applications. Hope it's yours favorite too, which is Notepad, and put this up here. And for the purpose of visibility, let's set the font to 16. There you go. So count and wait time. So, this is like what, let's call this as a baseline for the time being, and we are going to compare our performance with this. Now we are going to reconfigure Temp Db. So I'll come back to this file and add extra files. Now I'm reconfiguring Temp Db. So if you remember, one of the files I was not able to remove, which is temp7. So what I'm going to do is temp7 is something that I'm going to comment here. This is the one. So let me just comment this portion, temp7, and add the other one. So we'll add file 2, 3, 4, 5, 6. We are skipping 7 and we'll go and add 8. So 2 to 8 because one file already is there. So let's go and execute this. And this is done. And let's go and check how many files we have now. Scrolling up to see sys.data files. There you go. And now we have one log file and we have 8 data files. All right. And the idea is that we're going to run that workload again to see if the contention reduces and if the workload completes faster. Two things we are going to see. I've cleared off the wait stats again, and this is why you clear off, because if you have recorded the numbers safely somewhere, you can clear off. Let's go and check this. All reset back to 0 and time to run the workload again with 8 data files. So I'm double clicking on stress.cmd, starts off. Let's go back here and execute. The numbers are going up. Okay, so contention is happening, and your immediate question could be, hey Amit, contention is happening. Of course there will be contention because there are a lot of people trying to access TempDB at the same time, but what we got to see is that whether the contention has reduced or not. So looks like this is done now, and now this has taken 24 seconds, the same workload. So what took 32 seconds earlier has come down to 24. Well, depends on the dynamicity of how SQL Server is. This could go a little better because in previous run when I was testing it, it completed in 18 seconds. So sometimes 20, sometimes 18. But the point is I get 8 seconds of performance improvement here. So when you run this demo on your machines, you may get something better. But what about the numbers now? So let's go and copy and put the numbers here. And let's just do a bit of comparison here. So if you look at the first one there, page latch, SH and UP, these are the most ones, which is shared and update latches, 66K, 27K here. Update 132K and 54K. So you can already see that the numbers have come down by almost half, less than half. So that's performance improvement there. And one of our biggest wins, of course, here is the wait time in milliseconds for update. Remember, we were updating the tables, inserting the data. So 528K to 347K. Now, this is what I would do is add another 8 data files to TempDB to just kind of check, will 16 help me further? So, it's never ending. So you keep checking and then you find a fine balance. So that is the first best practice, and I can say that 99.99% times this could be a blanket recommendation to add more data files to TempDB. All right, friends, so this completes our first demo, and if there are questions, please use the chat window while I close this and open the other files.
I put a few useful links about TempDB best practices in the chat.
Perfect, very, very helpful. It's very important that you copy and paste all of them offline for your further reference. Next demo, let's jump over, and of course, questions can come in anytime. Second one, parallelism. So let's go and jump into Parallelism, and first we will open the helper file, and most demos are configured this way where I have helper, I have stress, and I have workload. So you understand the pattern that through this script I'm going to check a few things. This is the workload that is being called by the command file. So what are we going to see? First, what I am going to show you is how many max workers I have, and how many what's max worker being configured on the server here, a SQL Server, and how many threads I have right now on the system. And I'm going to give you the background in a while. So 576 is the max worker count for my SQL Server instance here. This gets computed automatically by SQL Server depending on whether it is 32-bit or 64-bit environment, and depending on the number of processors that we have. There is a formula for that. It's not important to go into the formula, but what's important to be known here is at any given point of time, theoretically, I can have 576 worker threads, and numbers will of course be plus minus a few numbers, but this is my limit there. Right now in SQL Server, I have 130 threads that are in the thread pool right now. So that's the number. Now, of course, all of you are thinking, what is this demo all about? Well, just wait for a few minutes and it will be clear what exactly am I going to talk about. Now, there is a workload here. If you look at this workload, the query seems to be very straightforward. In AdventureWorks 2016, we are selecting from sales order detail and we order by line total. This workload is as simple as this, a simple select with an order by clause. And then, like we always do, and we're going to do in all the demos, is stress SQL Server. But this time I'm going to stress pretty badly. I am going to show you the code. We are calling ostress as we did earlier, and I'm going to call this workload, the select statement that I just showed you. 200 threads are going to be called. 200 users are going to run that code, and each one of them are going to run that code 10 times. So that is how we are going to stress SQL Server right now. So that's quite a bit of stress for this poor VM on my laptop. Anyway, let's get started, and let's go back here and just let me show you the helper. So in the helper, I was only seeing this portion. There's one more thing I want to do here is when the workloads are running, I also want to see, apart from the count of threads, are there any tasks that are waiting? And let's call this as count star from sysdmo and waiting tasks, where the wait type is equal to thread pool. So I remember doing this, but I don't know why this wasn't saved. So let's see if this is running. So you can see no one is right now waiting on thread pool. So now this connection has to be converted to a DAC connection. What's the background? What am I trying to do here? Let's take a step back and try to understand. I'm going to run a workload with 200 users, and I'm assuming that workload will run in parallel, which means SQL Server will create a parallel plan for that and assign multiple threads, which means each session, each user, each connection that's running that workload will actually run the workload with multiple threads. And at that point of time, there will be so many threads, it will go beyond max worker thread. It will go beyond max worker thread. And then when I'm trying to run these helper queries to see what's going on inside SQL Server, this itself is not going to get a thread. That's the problem. My own helper query is not going to get a thread. So only for that purpose, I'm going to change the connection and put admin here. And I guess you all know that admin : the instance name here gives me a dedicated administrator connection. We use a DAC connection to go inside SQL Server via some exclusive channel when SQL Server is unresponsive. So we can use that. You can read the documentation to see what it really means. Anyway, so let's connect this. It says failed to connect, but it has actually connected. I don't know why that feeling comes, but you can see now it's an DAC admin connection there. So let's go and run this and execute this. So what is our number? 576 is max worker count. Currently, the number of thread is 130, and no tasks are waiting on thread pool wait type. I have not given you any background about wait types. I mean, of course, the session content is different, but I'm just assuming what that some of you, all of you know what wait types and wait stats concept is inside SQL Server. But here is a very quick background. When your query hits SQL Server, it needs resources. It needs memory, it needs CPU, it needs IO, it needs access to the data pages. It needs access to so many different types of resources. And practically speaking, in the lifetime of your query, when your queries are, your workloads are accessing these resources, those resources might not be immediately available and your query might have to wait. The good thing is when queries have to wait, SQL Server records that and you may capture that information to troubleshoot what your query was waiting for. What your query was waiting for is technically specified as a wait type inside SQL Server. In SQL Server 2019, there are more than close to 1,000 different wait types. Those are like classifications of different types of wait inside SQL. That's exactly what we are doing. In the previous demo, the wait type was page latch shared, page latch exclusive, and page latch update. And right now here, the wait type is thread pool. What does this wait type really mean? When a task is waiting for a thread to be assigned to it so that the task can run, the thread can be scheduled on the scheduler, but the thread is not available, the wait type for the task is thread pool. This is what I am trying to demonstrate to you now. Okay, friends. Fragile demo. This one is a fragile demo, which because the way it is 200 users. Let's stress SQL Server. It starts running. Go back to Management Studio. Let's see our numbers. Look at that. Instantly 576, and the number of threads are 600 something. If you saw that. Now our own query. Okay, look at this. This is the problem. Our own query in Management Studio, it was not getting the thread, so we get it 665, and number of threads that are waiting for thread pool are 29. So there are some tasks in SQL Server that are in the queue right now waiting for a thread to assign to it. And why a thread was not being assigned? Simply because our max limit is 576. We are already up beyond that threshold. We are at 665, and SQL Server under no circumstance can go beyond 665, at least on my system with my configuration of 8 CPUs. That's the max. So if I run this for another time, that's where this is. And you know, look at this. If I take this and I just do a new connection, if I try to run this, this is what happens. A connection was successfully established with the server, but then there was an error, etc., etc. There is no thread available right now, so connection, all connections are being refused. This is the problem. So let's go and terminate this batch now. Let's close this and close this. And if I now I've terminated the workload, so when you execute this, you can see now there are no more tasks waiting in there for thread pool, but the threads are at 665, which means these thread objects are created by Windows, of course, and was assigned to SQL Server, and now they're sitting in SQL Server thread pool, you know, the pool of threads, and they can be reused, reconsumed. If you restart SQL Server at this point in time, you will see that they are all set back to the default value. So let's just go and restart for me to show you that your thread pool and everything is going to be set back to normal. Max worker count be 576, and the current thread count will be 100 plus or something. That's what's going to happen. Okay, restart is done. And let's see what we have. Okay, there you go, 576. We are back to 116, which is kind of a default number there now. Could be plus minus something, and we are nothing waiting here in the waiting task. Now, what's the crux of the demo? Why did so many users wait? And the question really is, I ran the workload, I stressed SQL Server with only 200 threads here. If you look at this number, N200, and we were sitting at 130 when I ran the demo. So we could go over to like 230, 330, we could go up to 330 easily. But then it looked like that we were trying to go even beyond the max limit, and a lot of tasks were waiting for thread pool. The reason why that happened, and you all know that because I hinted you there, this query select star from sales order detail was the optimizer decided to run this query in parallel. So if I turn on the actual execution plan, let's change the database context to AdventureWorks 2016 and execute this. And the query is running now, and we jump over to the execution plan, you will see that SQL Server has assigned multiple threads to this query. It is running in parallel. The easiest and quickest indicator here is you can see the iterators with this arrow, yellow arrow icons there. So you know this is a plan with parallel operators. And how many threads each execution gets. So if I take the cursor over clustered index scan here and jump over to properties, you can see the actual number there, which is the number of rows, and there you go. So you can see that thread 0 is the controller thread there, and we have 8 threads from thread 1 to 8. Why did SQL Server assign 8 threads to our query? Because I have 8 CPUs on my machine. And I can just jump over to the task manager, go to performance and right click on CPU and change graph to logical processes. So you can see that I have 8 CPUs and SQL Server chooses to assign 1 thread for each CPU and I get 8, which means friends, technically, now we are coming to the climax of this demo. Technically, for each user, we had 8 threads, which means 200 users into 8. And theoretically, this was like SQL Server would try to create theoretically 1600. Is that number right? 8 to 16. Yes, 1600 threads. 1600 threads, of course, were way beyond our max number 576. Did that really happen? Did SQL Server really try to create? Well, I am not trying to get into those investigations at this moment because I think SQL Server did not even go up to that number. It didn't even touch beyond that because the number of tasks that were waiting were about 40, 50. But if I had waited for a bit longer, it could have only piled up. Okay, so all of you saw this and you have understood SQL Server tried to create so many threads because it wanted to run the query in parallel. It wanted to assign 8 threads to each execution. 200 users wanted to execute that query. So it wanted to create 1600 threads. It wasn't able to create. So many tasks were waiting in for thread pool wait type when they did not get the thread. So what is the demo? What are we trying to show? Well, for such a trivial query, for such a simple query like this, SQL Server chooses to parallelize the query. That is where the problem is. This query is very, very simple. It's not a costly query, it's a cheap query. But right now, SQL Server thinks that this is an expensive query and I should parallelize the query. I should create a parallel plan so that the query can be run faster. Why does that happen? Because there is a server level setting, and all of you know, I'm sure, which is cost threshold of parallelism. This setting, as we call that as CTP, cost threshold of parallelism, is the default value for which is 5. It's a very low value. This value 5 was set many years ago as a default value during times when we kind of have had computers with very low memory and kind of probably single processors, you know, not like today's world with hundreds of processors. So during those days, 5 was a reasonable value, but now 5 is not a reasonable value. And that is the reason why almost every query that crosses that number of 5 in terms of cost gets parallelized. Which means now if I take this query and just to show you, if I say option max top 1, if this query was running as a serial query, which means with a single thread, let's go and execute this and jump over to the execution plan. You can now see it's a serial plan, no parallelism. You can see those icons are not there. Take the cursor over the select operator and you can look at the estimated subtree cost, which is 10.4929. What does this mean? This is the cost of the query. So estimated subtree cost beyond the select operator is actually the cost of the query. And the cost of the query right now is 10.4. There is no unit of measurement here, mind you. Some documentation say that CTP means the number of seconds and all of that. I don't know. I mean, 10 years, 20 years back, probably that documentation made sense. But right now, this is just a number. It is just a unit. So 10.4 is obviously higher than 5. And now I'm showing you the cost of the plan when it is serial. So this is higher than 5. So SQL Server decides to parallelize the query. And of course, the parallel version of the query, whatever that cost is, it is. But what we need to see, what's the cost of the query when it was serial? So this is how it happens. CTP value is 5. When your query goes to the optimizer would first prepare a serial plan internally. It will first prepare a serial plan. It will see what's the cost of the serial plan. Let me technically correct myself. It wouldn't prepare the plan, so to say, but it will compute the cost of the serial plan. And the cost of the serial plan in this case is 10.4. So is it higher than 5? Yes, it is higher than 5. So there goes the optimizer. Now it will create the parallel version of the plan and output that plan. And that is the reason, friends, this query, a simple query which just executes in a few milliseconds, is perceived to be expensive because the numbers are so low, and each execution gets 8 threads. 200 users are trying to run this in parallel simultaneously. That is where all the problem and all the wait for the thread happens. So what do you need to do? Another best practice, another speedometer technique here is just go and reset CTP to a higher value, to a better value. This is also one of the best practices, an immediate thing that you should do post installation. So cost threshold of parallelism right now is 5 here. Just for the purpose of demo, I'm going to set it to 20 and click on OK. And I'm going to remove this mag stop and run this. Now you will see that I have changed this value from 5 to 20. We know that the cost is 10, so this, which means it's not going to be converted to a parallel plan. Let's go and execute this. Jump over to the execution plan, and you can see that it is not a parallel plan anymore. By default, it's a serial plan. So friends, what does this mean? That if we go and run, we stress SQL Server back again here now, 200 users, hopefully we will only require precisely 200 more threads. We will not need 200 into 8 because each execution is going to be serial. Let's go and execute this. It's running. Jump over here, execute, and everything is nice now. You see that? 576, we are at 299. So of course, some threads were reused, which were there in the thread pool. So it's not a straight away jump of 200, but what you can clearly see that nothing is really waiting in the waiting tasks there. Nothing is waiting on thread pool, and all these. And if I create a new connection, even in Management Studio, I get handshake issue again. But let's try this once more. This seems to be okay. I am trying to connect admin, so this should not be admin. Will I get a normal connection? Because you're allowed only one DAC connection. I didn't figure that out earlier, but anyway, and you execute, and hopefully everything will be running fine. There you go. So this was, friends, the second demo. Let's terminate this batch.
There is a question, Amit.
Yes.
Is there a method to monitor and alert about this thread starvation you demonstrated earlier with the thread pool wait type?
Sorry, the question is?
How do you monitor the thread starvation scenario with the thread pool wait type?
Okay.
What can you do about it when it happens?
What can you do about it when it happens? Well, the easiest way how we monitor is this DMV, sysdm OS waiting tasks. This is a real-time DMV. If we just simply do a select star from this, it gives me a list of all the tasks that are waiting on the resources. And what we do is, of course, if you're doing this in Management Studio in a raw way with T-SQL, then you can use these. But ideally, as you know, most SQL deployments would have a Redgate monitor tool or IDERA or SQL Sentry or SolarWinds or something, or maybe a free tool where there is a UI which shows you what are the tasks currently waiting on, right? And you can group by. You can group by on the wait type. I mean, this is what I do. So I do account there and I group by on the wait type, right? So I get to see how many threads are waiting on a specific wait type on a real-time basis. That's the quickest way. The second is you can run extended events to capture all of this, but I think DMV will be, of course, much faster. Extended events would just add slightly marginal overhead there. The third way is to use perfmon counters. For wait types, I don't tend to use perfmon counters, but I think in perfmon counters also there may be some counter or object there. But if you ask me, this here, this DMV is my weapon really.
Thanks.
And
another question, what is the optimal value for CTFP, cost pressure for parallelism?
What is the optimal value? Great question. I was expecting this would come. There is no predefined number. No one has ever recommended, people have recommended like 30, 40, 50, 60 or anything to go with. I would say you could start off with like 30 or 40, something around that, or maybe even 50, but then fine tune it. Because the value that you start with, of course, will not be permanent, but keep monitoring. And it's a much larger discussion about how do you fine tune it. What do you monitor? How do you see parallelism inside SQL Server? Then you have to monitor another wait type called CX packet. And now in latest versions of SQL Server, another wait type got added called CX consumer. So it's, as you all know, it goes a little more deeper to observe parallelism inside SQL Server and constantly monitor, take down your numbers, make a baseline, keep observing peak hours, non-peak hours, and then continue to fine tune it. And at some point, you will get your best value for CTP. So it's a larger job there. Yeah.
Thanks. Again, I've put a few useful links in the chat. The last link I just put is a nice article by Eitan Blumin, exactly about how to monitor your specific workload for parallelism and optimize and fine tune the best value for the CTFP.
Perfect. That I'm sure that blog post which Guy has put, that is a session in itself, hopefully.
Yeah.
Okay, so I hope you got this demo, and I did spend quality time because it's not about rushing through all the demos and just trying to complete all the 6 techniques, but the idea is, given the time that I have, whatever techniques I can complete, I want to complete them in fullest so that you understand what's going on. So just to quickly summarize, what I did in this one really was, the default CTP is a low value, because of which so many threads are getting created. And there's one more background to this. This question has not come, but I let me ask this question on your behalf. You might be wondering, hey Amit, what did you do? You took this query and SQL Server decided to parallelize it. And of course, so many threads were being wanted. So you saw that there was thread pool wait type. So you increased CTP, forcing this query to go into serial mode, thereby reducing the number of threads. All great. But then what about the execution performance of the query? Would not the total response time of the query also increase now? Because earlier it was running with 8 threads and theoretically it could have run much faster, but now you're forcing the query to run with a single thread. So what about the performance of the workload itself? Here is the catch. The catch is optimizer only does estimation. So do not only always go by the estimation of the optimizer, you also need to go by the actual runtime statistics. So when you run the query, like this simple select statement, what would you monitor? You will look at the elapsed time, the total time it has taken for the query to run. You will look at the CPU time. And of course, you will also look at reads, writes, etc. But in our case here, reads, writes won't change. It will read what it has to read, whether it is 1 thread or 8 threads. But what might change is elapsed time and CPU time. These are the 2 things that might change. You got to monitor that. I don't have time right now to show that to you, but you should do this when you take the scripts back and try this around. Run this query with 8 threads and then run this query with single thread. Compare CPU time and elapsed time. You would be surprised. The conclusion that you will see is there's hardly any difference. In fact, with the single thread, and of course it makes sense technically, right? With the single thread, CPU time is lesser because of course 8 threads consuming CPU cycles versus 1 thread consuming CPU cycles. the amount of work that has to be done with 8 threads actually increases because of that coordination of 8 threads by the controller thread. So there are more CPU cycles being spent there. The job can very well be done with a single thread. So elapsed time more or less remains same. You would see a difference of just a few milliseconds, but CPU time goes down. So in our real world, as we say, if you're a project lead, you're a team leader, you're a project manager, you're executing a project, just by adding more people, more resources to your project doesn't mean that the project is going to complete faster. Sometimes that same project with more people adds a bit of extra overhead, and the amount of time it takes is just same or slightly more. So the bottom line here is, when you do this, you will see that the serial version of the query is as good, and of course takes less CPU time. So the conclusion here is there are many such chatty workloads inside SQL Server. I call this chatty workload because it's a very simple query that just comes in, runs in a few milliseconds, pushes off. Chatty workload. There are many such chatty workloads inside SQL Server in typical OLTP environment that that need not be parallelized. They are good and happy with single thread, and that's the whole objective. That is the whole objective of increasing the CTP value to a higher number, so that you're not wasting threads. Very simple, and you keep more room for other incoming queries to come in, and there are more threads in the thread pool, and no one is waiting on thread pool wait type. That's where this is. Okay, friends, this completes the second technique. I've done this session before, but today I don't know where am I going wrong. It is taking much more time than expected. Okay, so
another question.
yes.
Where do we see parallelism shine, and how safe is it to change the cost default?
Yeah, where do we see parallelism?
When parallelism will work better for queries.
Okay.
And when it's not.
Okay, so this is a very
because
difficult
what you
question.
demonstrated here, you talked about the query that if you change it to max.1,
Yeah.
it will still behave the same, more or less. So the question is, in what situations the query will behave better under parallelism, on the parallel plan?
Okay, of course. So let me put it this way. If I'm changing the CTP value to a higher value, let's say I'm putting the default value of 50, there could be some queries or workloads that are in genuine need of parallelism, right? Which really might be benefited with multiple threads, and even they will be forced to run in serial execution, and it might be bad for them. That will happen. That will happen. So there is, in a way, the idea is there is a trade-off here, right? You're doing a trade-off. So there could be complex queries that are really expensive, and you need parallel threads. So let's say you're doing a huge scan on a large table, right? And you definitely, with multiple threads, it will really benefit. Think about a table with millions and billions of rows, right? Partitioning, for example, right? When you have a huge table being partitioned and the file groups of those partitions are put in separate LUNs, for example. Awesome example of parallelism. So yeah, you got to play. I mean, it's a trade-off. If you have more of such workloads, then that is the whole idea about fine-tuning as to where do you draw your line. Let's say the cost of those queries is 40, then you want to make sure that you don't increase your CTP beyond 35. I'm just giving you an example, right? Offhand. Because if you set it to 50, even those ones that are in genuine need of parallelism, they will be forced to serialize. So sorry, this is not the best answer I could give, because there's really no a straightforward answer to this. It's all about trade-off, because there's so many variety of workloads that are running.
I'd like to comment, Amit, on that. I think that's a wonderful example. I think that running on a huge table, a vast amount of data, while being, stored on different partitions, that's a wonderful use case where parallelism can really benefit you. And in general, to Liat's question, I don't think that I would recommend her to just change the cost default, but to look maybe on a much smaller resolution, meaning to evaluate each and every query to its own. Maybe some queries would benefit from, a higher degree of parallelism, and you can just, tweak it on the query level. That would, I think, much safer approach than change it for the entire server.
Yes, yes, absolutely. Thank you so much for that comment. And in fact, if all of you observed, I use this hint option max stop one. So I will tell you there were customers who kind of refused to change CTP beyond a certain point, and to really ensure that there was no excessive parallelism to some queries, we actually put this hint max stop one. Sometimes we put max stop four, and some of us know that there are best practices that you could use max stop even at server level. Again, this is a larger discussion going deeper into parallelism, where you set the max stop to, let's say, equal to the number of NUMA pods, NUMA groups that we have on the hardware. That's another way to treat excessive parallelism. Right now, max stop at the server level is one, which means use all the threads. So if I had, let's say, 64, max is 64, as we know in parallelism in SQL Server. So if I had 64 threads for this query, also SQL Server will happily take 64 threads just for this execution. So I can set max stop to, let's say, 4 or 8 at the server level to ensure that, okay, no query goes beyond 4 or 8. So as we know, there are many of these options. Query hint sometimes is not very practical because we don't really go get this opportunity to change the code which is coming from client application or ISV and whatnot. So all we have is we can play around inside SQL Server without touching application code. But I am sure the link that Guy has given, and there are more recommendations even by Microsoft. What are the different things that you can do? CTP, max stop, query hint, setting max stop to the number of NUMA nodes. There are all these options available at our disposal to deal with excessive parallelism. The larger discussion is dealing with excessive parallelism here.
Yeah.
Okay, friends. Guy was just checking how much time I have and how many more demos can I run.
15 minutes.
Okay, so friends, let's go with one more demo, and I know, and all of us know that I won't be able to complete all the demos, which is not bad because maybe Guy will give me another opportunity sometime in future as part 2 to complete 4, 5, and 6 maybe, and it's great. It will be a good follow up. So let's start with optimize for ad hoc workloads, and let's see if we can complete this in 15 minutes. So again, there is, again, before we begin, I will have to quickly restart SQL Server just to reset back. Okay, I didn't change the setting at the server level. I need to do that. Set it to back to 5. Okay, and restart. I hope all of you are enjoying the demo, and this of course is getting recorded, so hopefully some of you will watch the recordings. And really the best way to learn is to do it yourself. You will have the scripts, you will have the recordings. The virtual world has there's one good thing about this virtual world, because in physical in-person events, we know recording sessions with physical equipments is is a costly affair nowadays, getting all the cameras and everything. So
yeah.
Virtual world makes it really easy, and we can, in no time, it goes up on YouTube and you can watch again and pause and play and practice. Okay, so let me first open up all the scripts, because even I need to just kind of see what each script contains. Okay. So we have helper, set mem, and then stress, and here is the workload. Okay, I'll close the workload. It's a 7 MB file there. Okay, what are we trying to do with optimize for ad hoc workload? Here is a quick background. When your query goes to SQL Server, like an ad hoc query, I'm not talking about stored procedures. I'm not talking about compiled objects. I'm talking about ad hoc query. What is an ad hoc query? A client establishing a connection and firing a select statement. A very classic example of an ad hoc query. So when an ad hoc query goes to SQL Server will prepare an execution plan for it, store the execution plan in the plan cache. And you all know why, because SQL Server wants to reuse that plan, provided that query comes in a second time and a third time and a fourth time. So plan reuse is good. SQL Server loves reusing a plan, because creating a plan, optimizing it, compiling it, it is a CPU intensive process. And in OLTP environment, the same workloads keep coming in all the time, again and again and again, maybe with different parameter values, maybe with the same parameter values. And that's why SQL Server wants to store them in a plan cache. We call this as a plan cache and wants to reuse it. That's a very short, very a very quick overview of the plan cache and the plan. Now, there could be scenarios in OLTP environment, and we know in OLTP this happens is a lot of these queries, the ad hoc queries that come in, they come only once. They don't come a second time. That's a typical nature of how OLTP applications are. Think about hundreds and thousands of customers. Think about hundreds and thousands of sales users. I mean, insurance companies, customers would just log in via an app or a website and simply just query when is their next EMI or something like that. So the query is as simple as select EMI from this where customer ID is X, and it comes once. That's it. And now that query is not going to come a second time, at least not with that customer ID. So that is the basic nature of a select statement, an ad hoc query. And so where is the problem? The problem is if SQL Server will create a plan for that query, it keeps it in the plan cache until whatever time, until it automatically gets kicked out, etc. That's a different discussion, but it keeps it inside the plan cache, waiting in anticipation that the same query will come again. And that same query betrays SQL Server, never comes again, never comes back ever again. And that plan is just waiting and sitting idle in the plan cache. If a lot of that happens, friends, if a lot of that happens, this is what we call as plan cache bloating. You may actually see thousands and thousands of plans, ad hoc plans sitting in the plan cache, which are called as single use plans. Their use count in the plan cache is 1. Why? Because so many ad hoc queries have come in, they hit, they ran, they came and they went away. They never came a second time. In order to manage plan cache better, because plan cache has a limited amount of memory. SQL Server would not give all of its memory to buffer pool or plan cache. There is a certain percentage that goes to it, and plan cache has limited entries. The maximum can go up to 160 by default, 160,000 something, 164 or something to be precise. Those are the total amount number of buckets that can be created there. So we got to manage this better, and I will show you with real numbers now. So what we will do at the server level, there is a setting called optimize for ad hoc workload. When you turn on, so let me do this. Let me not talk about optimize for ad hoc workload. Whatever I just talked about now, let me first show that to you quickly. So I am going to first set the memory to 1500 MB. I am just doing this for the purpose of demo. Okay, I've changed the SQL Server memory to 1500 MB, close to 1.5 GB, because by default right now I have close to 10 GB, and only for the demo I did that. And now let's go to the helper query here. So we have let's run this helper query. So what you see right now is SQL Server has about 529 MB being used by the process. These are the examples of some queries out there, if you see. And there are only 4 plans in the plan cache right now, and buffer pool is the clerk that's right on the top. This is a memory clerk. Memory clerk will not get into that, but the idea is I'm just trying to show you different memory consumers here. And at some point you will see that plan cache as a memory consumer will come on top. Now I have, what I'm going to do is stress SQL Server. This is going to again call workload. One user is going to run it only once. That's all ostress is going to do. This is the file workload.sql. What does workload.sql do? Let me open it quickly for you. Workload.sql Server has these ad hoc queries. Select something from employees table where manager ID is equal to 1, and friends, it goes all the way to 50,000. That's what this query is. 16,000 manager ID, right? I mean, huge company with a lot of managers. Looks like they're only managers. There's no one under them. Anyway, so this is the workload that's going to be called. And you know what's going to happen now, right? Each query is an ad hoc query. It's going to be treated. There will be no parameterization here. Parameterization is again a different discussion altogether, but each will have its own plan. That's where the problem is. So let's go and run this. Now this is slightly engineered. I mean, not very realistic, so to say. I mean, nothing comes in like 50,000 at one stretch, but I mean, just engineering it a bit, because you may have a variety of queries with variety of parameter values. But anyway, This will at least explain us what's going on. So I am going to just close this not to get confused, and I'm going to comment some of this because there's a lot of code out here which I don't need right now, and I should not run them by default. I may overshoot my time a bit for the session. I hope it's okay with Guy. So let's go and execute this. There you go. We're all set, friends. Ready? 528. These are examples of certain plans. Total number of plans right now in the plan cache is 17. And you can see clerk here. Right now, buffer pool is on top. Let's go and run the workload. We will also observe how much time it takes for the workload to complete. Okay, the workload has started. So which means that SQL file with that query, 50,000 of those are being called. Let's go and execute and see. Keep observing the physical memory for the process is going up. You can see lot of compiled plans here. Look at cache object type, compiled plans. Look at object type ad hoc, many of them now. Total number of plans are touching 5,000, and in no time you see cache store SQL CP, which is the clerk, comes right on top, which is consuming about what, 255 MB or so, approximately pages KB. Let's go and run this again, because by the time I was explaining you, something happened, which is SQL Server has crossed over 1 GB of memory consumption. Again, a lot of plans in the plan cache. How many? All compiled plans ad hoc, as you can see. And total number of plans are crossing 8,000. You know what, friends? That SQL file has 50,000 queries. Select something from that employee table where manager ID is equal to 1 all the way to 50,000. So in ideal world, this should actually touch 50,000, but it will not, because you know I set the max memory to 1500, right? And we are already 1 GB. So SQL Server won't be able to store so many plans in the plan cache. Instead, it's going to kick out those plans, and kind of there's going to be a high churn, but that's not important. What's important for us is to just keep observing this entire thing. We have gone all the way to 10,000. Physical memory is just 1 GB right now here. 547 clerk SQL CP is consuming about half a GB of it now. You can see that. Typically in production system, buffer pool is the clerk that comes right on the top in most cases, but here the scene is a bit different. Do you see this now? From 10,000, we scale back to 7261, which means a chunk of plans were kicked out of the plan cache. This is all happening real time. Where are we? Okay, this is done, friends, and this has taken 1 minute 36 seconds for the overall execution to complete. So keep this number in mind, 1 minute 36 seconds. Let's close this. Now what we are going to do is right click, go to properties, and turn on a setting here called optimize for ad hoc workload. And where is that fellow? Optimize for ad hoc workload. There you go. Okay, so if you see right now, this is false at server level. This is not at database level. So we change it to true, and I click on OK, and I'm going to restart for a fair comparison. Okay, while it restarts, I'll quickly explain you for the sake of time. Now, when you set optimize for ad hoc workload on, you are explicitly telling SQL Server that I have many ad hoc workloads that come only once. They are single use queries. They don't come a second time. So please run them, create a plan for them, run them, but do not store the execution plan in the plan cache. So SQL Server will not store the complete plan. It will only store a very small amount of signature, which we call a stub. It's called a stub, which only consumes a few hundred bytes, probably 200 to 300 bytes. That's it. That stub is important. Why? Because optimize for ad hoc workload means that the first time the complete execution plan is not stored, but if the same query comes a second time, the stubs will match. And then SQL Server will decide, oh, wow, this query is coming a second time, which means it has the potential to execute more than once. And that is when the execution plan of the query is going to be stored. So that's why that stub gets stored. So what you got to observe, keep these numbers in mind. We went to 1 GB. We had about 10,000 plans. SQL plans here was taking about half a GB or so. Now, when you run this, we have restarted SQL Server. We're sitting at 400 MB with the process. There are 82 plans in the plan cache. SQL CP is not here on top 5, top 10 right now because the workload is not running. And the workload took earlier 1 minute 36 seconds. Optimize for ad hoc workload is turned on, and we are stressing SQL Server again. Let's go and see what's happening now. Okay, so plans are being consumed. Okay, there you go. If you see, we are quickly climbing up to the number of plans. So look at the total memory. We're still 400 and the number of plans in the plan cache are about 7,000 now very quickly. Look at these. These are not compiled plans. You see a new cache object type here which says compiled plan stub. These are the stubs. Hundreds of stubs are there now, but not the complete plans. And they're only few hundred in bytes. That's why the consumption by SQL CP is not here. Okay, there you go. This is the fellow here sitting there with just 12 MB of consumption. Remember, this number here was about half a GB earlier, and we are already in 7,000 of those objects in the plan cache. Huge optimization that we can see real time. So let's go and execute this again as we are running. Wow, there you go, friends. 30,000 with the same amount of memory now, 1500, what we set for SQL Server. We have 30,000, but I will not call them plans because you know they're stubs. They're not plans. So 30,000 objects in the plan cache. SQL CP is somewhere, where are you? There you go, with about 45 MB. SQL Server memory right now is just about 400 MB. Remember last time we crossed about a GB. And let's go and run this once more. Finally, 47,000. Wow. So friends, we had this query with 50,000 queries, right? Manager ID 1 to manager ID 50. We're almost at 47. Are we done? We are done. Should have run a much faster. Don't know why it took 1 minute 34 seconds. But anyway, that's why I said demos are fragile. But in my previous run, when I was trying to test this, this goes a little faster, but nonetheless. So what you see, the execution is complete, and look at the overall optimization of SQL Server here. Remember, optimize for ad hoc workload is not about improving. It's not about improving CPU time or total execution time. I do keep an eye on that and I record that just to understand. But the overall improvement here is memory, friends. Memory is the key here. Avoiding plan cache bloating. I have 50,000 objects in plan cache now. This is right in front of you. All of them are stubs. The total consumption of the plan cache is just about 70 MB or so. And SQL Server's memory consumption is just less than 500 MB in comparison to what we saw earlier, and everything ran beautifully. So that is a great setting for OLTP environments. And of course, not a blanket recommendation, but you may want to evaluate. So we have done Temp Db, Parallelism, which is cost threshold of parallelism, and optimize for ad hoc workloads. And of course, the follow-up demos were these three, which unfortunately I'm not able to complete today. But I think whatever you got in this last 1 hour was very useful to you. I hope so. And of course, we should have some another opportunity after Guy knows there's a big event coming up, which I do, which is Data Platform Virtual Summit in September. Hopefully, he can share the link for that as well. After September, I'll request Guy for another session to complete the remaining 3 demos. With this, thank you so very much, and happy to take more questions.
Thank you very much, Amit. It was a great session. I put the link to the Data Platform Virtual Summit, so make sure you register in September. It's in the chat.
Thank you.
And any questions for Amit? Mail says he's hoping for a part 2. So
all right.
Yeah, me too.
Me too. We are all. If you're on Twitter, do give some feedback as well. A_Bansal is where I am, and all resources are there in this link. Or you can just go to SQLmaestros.com and jump over to the resources section. The top row you will see in the table will be Israel Data Platform Meetup July 2021, and you can download the scripts and videos. Recording, of course, will be made available by Guy and his team. Thank you.
Sure. Excellent. Well, great. I see no questions. So thank you very much, Amit.
Thank you.
It was a great session.
Thank you. Yes.
And good luck with the summit in September. And we'll see you again sometime after that, I guess, for part 2.
Yes, absolutely. Thank you very much, friends, for joining today. Hope it was worth your time. We wish you a good day, rest of whatever is left over for the day, and stay safe, keep happy. Thank you, Guy, for the opportunity. Lovely time here with all of you. Thank you so much. Goodbye.
Thank you very much. Thank you. Bye.